So now we'll learn how to design a DFA accepting strings of length 1. First of all, the input alphabets are given 0, 1. So we'll write all the 1-bit combinations. 1-bit combinations are either 0 or 1. So the minimum length string is 0 or 1, which is of length 1. So the number of states will be 2. So 1 will be your initial state represented with Q0 and put in an arrow. Then we'll have a final state, that is Q1, represented by concentric circle. Now just input your 0 as well as your 1. So if you start from Q0, you reach to Q1. If you follow this transition, you will accept 0, and if you follow this transition, you will accept 1. So for this state, I have made the transitions for both 0 and 1, and I am left with this particular state. If I try to put a self loop of 0 or 1, it is going to increase the length of the string. So it will accept 0, 0. It will also accept 0, 0, 0. So it is going to accept strings of more than length 1. So we cannot have a self loop of zeros and 1s. We cannot also have a transition on the back side, because again it is going to increase the length of the string. So in this case, when we cannot have a transition on Q0 as well as on Q1, so the need of dead state arises, that is a non-final state. So we'll simply put the transition of 0 and 1 on some other state, let's say Q2, and this is also called as a dead state. Dead state is nothing but just a non-final state, and on this state we'll simply put the transition of zeros and ones this way. So whenever any string which is trying to be of length more than 1, it is not being accepted. Why? Because after the final state we are reaching to the non-final state. So in this way we can say that we have designed a DFA which is accepting only the strings of length 1, and whatever strings of length more than 1, that is 2, 3, 4 are coming, they will be accepted by the non-final state. So this the introduction of this dead state is going to eliminate all the possibilities which are of length 1. So here we are done with this example. And now coming to the second question, now we have to design a DFA which is accepting all the strings of length 2. Again we'll write all the 2-bit combinations, that is 0, 0, 0, 1, 1, 0 and 1, 1. So minimum length string is 2, so the number of states will be 2 plus 1, that is 3. So first will be your initial state Q0, then we'll have one more state, that is your intermediary state, and the third state, that is your Q2, that is your final state. Now we can have, on this state we have to balance the 0, 1. We have to make the transition for all the given states. For this state I have made the transition for 0, 1 this way. Similarly 0, 1. So if I have to check whether all these strings are accepted or not, see, 0, 0 is accepted, 0, 1 is accepted, 1, 0 is accepted, and 1, 1 is also accepted. So all the 4 strings are accepted. If you will try to make the self loop, the length of the strings will increase, and if you try to make the transitions over Q1 or Q0 for the given input alphabet 0 and 1, again the length of the string is going to increase. So we are left with the option of introduction of a dead state, that is putting this transition on the dead state, that is a non-final state Q3, and on Q3 we'll have a self loop of 0 and 1. So again, after the length of 2, whenever length 3, 4 is going to come, then it will fall under this dead state and it will not let this length of the string increase. So in this way, this is restricting the length of the string to 2 only. Thank you.